So hello, everybody. I am today talking with Michael Osland, USGS Wetlands and Aquatic Research Scientist in Lafayette, Louisiana. And Dr. Osland is studying habitat transformation across the Southeast coastal zone. So to get started, I want to ask you about your current work, Dr. Osland. And I know you study coastal habitat transformation, but can you tell us how this even happens to begin with and what kind of particular habitats we're thinking about?
Yeah, so a lot of my work focuses on coastal wetlands, and so those habitats include mangrove forests, salt marshes, or also areas that don't have plants. We call those salt flats. So those are the general coastal wetland types that I tend to focus on.
Awesome. And so what tends to cause this transition? Is it what are some of the main drivers for those things?
Well, so coastal wetlands are super vulnerable to a lot of different aspects of climate change and also land use change. And so my work has focused on different components of that change. One key aspect is sea level rise. So rise in seas can result in really large coastal transformations. And so some of my work focuses on sea level rise. A really big chunk focuses on changes in temperature. And so within our region, we have, we're located near the northern range limit of mangrove forests. And that range limit is controlled by the duration, the frequency and intensity of extreme freeze events. So these are, rather than average temperatures, these are cold events that occur very rarely, once every decade, 2 decades. A really good example of that would be the recent freeze event that occurred in Texas. And so those types of events, they don't occur very often, but they control the range limit of mangrove forests and a lot of other tropical organisms, sea turtles, manatee, fish, the list goes on and on. And so yeah, that's one particular aspect of coastal wetland transformation that I've done a lot of work. I've gotten really interested in, and I've done a lot of work. So the influence of extreme freeze events on the northern range limit of mangroves.
What are the main differences between like the black and the red mangroves? I think those are the primary species in the US, and I guess are there differences in their temperature thresholds?
Yeah, there's one more. So there's 3 really common species: the black mangrove, which is Abyssinia germinans; the red mangrove, which is Rhizophora manglae; and then the white mangrove, which is Laguncularia racemosa. So in South Florida, all 3 of those species are very, very common, and even into Central Florida. But the black mangrove, Abyssinia germinans, is the most freeze tolerant, freeze resistant. So that's the species that tends to be located at these northern range limits.
Okay.
And so so the black mangrove is present in Louisiana, and it's fairly common in Louisiana and Texas. There are no red mangroves in Louisiana. There's a few in Texas. And then the Florida range limit actually has a combination of the 2, which is kind of different. Yeah. But yeah, in general, the black mangrove is the most freeze resistant, the freeze tolerant of the 3. So it tends to spread further north.
Yeah. Okay. And so some of your recent work has talked about the spread of mangroves, the loss of salt marshes, correct? And so my question is, what are the big differences between like the ecosystem services that salt marshes offer versus mangroves?
So yeah, and that's kind of a complicated question, and it really depends on individuals' perspectives, because both salt marshes and mangrove forests are, they're among the most valuable ecosystems on the planet for the many ecosystem services that they both provide. And the list in terms of those services goes on and on and on. So coastal protection is a really good example. The support of fisheries and seafood and coastal food webs, their ability to store carbon, their ability to support habitat for fish and wildlife, their ability to improve water quality. Let's see. I mean, there's a lot more ecosystem goods and services provided by those 2.
Mhm.
And so it's not there's not an easy answer for you because there's trade-offs. And it's a pretty big transformation for a salt marsh to be encroached on by a mangrove, because you have a switch from a grassland to a forest. There's big differences in the structure and function of the ecosystem. So it really, my answer is it depends. There's really big changes in above ground carbon storage. So there's a lot more carbon that's stored in mangrove forests above ground than in those grasslands. We're finding that the implications for below ground soil carbon storage are more nuanced. In some areas, there's an increase. In other areas, there's not a difference between the two. And it may be influenced by precipitation and the type of marsh that's being invaded. So that's an answer for carbon. In terms of the ability of the ecosystems to keep up with sea level rise, there's a need for more research on that question, and the results are nuanced as well.
Yeah.
Where there are really big shifts, and what's particularly concerning are the effects on habitat.
Okay.
So one really good example would be the Aransas National Wildlife Refuge in Texas, which is a really important area for whooping cranes. And so the marsh provide important habitat for the whooping cranes. And so their managers are really concerned about the implications of mangrove expansion. Mangroves are present there and expanding on that whooping crane population. Let's see, where there are houses, mangroves can affect the view of homeowners. And so that's a real tangible concern. In terms of coastal protection, there's the potential that mangrove forests may protect coastlines better due to the increase in friction and structure. So yeah, there's not, I wish I could tell you, well, it's bad or good. The answer is it really depends, and it depends on what local land managers and coastal communities value.
If mangroves start to shift north and we see these massive freeze events, is there a possibility that our coastal wetlands and ecosystems could be more vulnerable to open water transition because we'll have these extreme events?
Yeah, potentially. So the way I'm envisioning it is that with mangrove range expansion, there's going to be these cycles of expansion and contraction, and that's what's happened in the past. And as we have warming temperatures, we expect mangroves to expand. But yeah, exactly. As we get these extreme events like the one that occurred in Texas, those expanding mangroves will be affected by those freeze events. And if they're, to answer your question specifically, if they're severe enough, yes, there is the potential for peak collapse. So you could envision a marsh that's been replaced by a mangrove forest, and there aren't very many marsh propagules or individuals around to establish in an area where mangroves have been killed. It's potential that the peat, the organic matter beneath that mangrove forest, could actually collapse, resulting in the conversion to open water.
Yeah.
Now, while that's possible, and it has occurred related to hurricanes and other extreme events, there's not good evidence that it's happened related to a freeze event, although it's definitely possible. And that's a really good reason why there's a lot of interest across the Gulf in planting mangroves beyond their range limit. And that's a primary reason why I tend to tell people that's not necessarily a good idea, because if you get mangroves to establish and then there is a freeze event, then you lose all that vegetation and you could accelerate the conversion to open water.
So one of the most recent papers I read was your 2020 paper that focused on more than just mangroves. And I have to say, it terrified me of the thought that Burmese pythons could move further north. And so like this paper talked about a lot of different species, like plants and animals alike, a lot of which are invasive species. So my question is, what are the biggest challenges that these projected changes and range expansions will bring to natural resource managers?
And in terms of range expansion and the tropicalization, you really highlighted a really important point, in that there are a lot of invasive species, be they native or non-native, but especially those introduced species like the Burmese python, the Brazilian pepper tree, insects, some mosquito species that are extremely problematic where they're currently located. And as they spread north, they'll cause problems beyond their current distribution. Yeah, and then there's a lot of reptile species as well, like the python and the Cuban tree frog. There's a lot of those species that they have traits that enable them to respond to climate change. And if they're able to move north, I view it as very problematic. But back to your question about what can be done, I think that for introduced non-native species, there's really a lot that can be done in terms of, once an invasive species is established in an area, in some cases, there's very little that can be done to manage it, or to manage it's going to be super expensive. But for these areas where species are just starting to get into, that's where management can really have an effect. So if managers are aware of the problems caused by these species, and they can pay attention and be on alert for their appearance within, say, their refuge, then it's much easier to manage the species at that point, before they become established and there's a really robust population.
Yeah. So one of your papers discussed like the entire range expansion. So can you reiterate what that range expansion looks like under the different climate change scenarios that we have?
So black mangroves are currently located in Texas, and throughout much of the state of Texas, from the border of Mexico and then also near the Louisiana border. There's a gap in the mangrove distribution in Louisiana in an area called the Cheniere Plain, which is kind of it's western Louisiana, between the Mississippi River Delta area and the Texas border. And so there's a gap there because it's colder. It's currently colder in that, so mangroves aren't very abundant there. In Louisiana, mangroves are abundant along the southeast outer coast. So in Louisiana, there's a land ocean temperature gradient where these freeze events tend to be colder further inland. And then those temperatures get warmed up by water and coastal wetlands. And so they're much warmer by the time they reach the barrier islands. And so that's where mangroves tend to be, on barrier islands and then the outer fringe. And that's the case in Louisiana. There are a few isolated mangroves on Mississippi's barrier islands, but not on the mainland. And then there aren't any in Alabama. Now in Florida, the mangrove range limit is on both coasts, so the Atlantic coast and the Gulf Coast. The range limits on the Gulf Coast are in an area called Cedar Key, and then also Apalachicola, and on the Atlantic coast near St. Augustine. So that gives you an idea of where they're currently located. In terms of the spread, so they've been spread in locally in all those areas really since the last major freeze event, which occurred in December of 1989. And so in all those areas, they've been spread in and becoming more abundant locally. Now, in the long term, mangroves, my expectation is that mangroves will be much more abundant in Texas. So most of the salt marshes in the long term, now I'm talking by the end of the century, by 2100, that salt marshes in Texas and Louisiana would be replaced by mangroves. And as you're an expert in sea level rise, so that is also going to be heavily influenced by sea level rise. So a lot of these wetlands are going to be moving inland, migrating landward with that saltwater intrusion. And so as mangroves replace salt marsh, it may not be in their current location. All those tidal saline wetlands are going to have to move inland in response to sea level rise. So those are going to be two really big hot spots in terms of mangrove replacement of salt marsh, Louisiana and Texas, but then also North Florida.
You've said that the major limiting factor on the expansion of the mangroves is the winter minimums, but do mangroves also grow within like a salinity range as well?
They do, yeah. And a really good way of thinking about that would be the Everglades. And so that's a really unique ecosystem. And there you have the reverse of what you study. You study marsh. Your tidal saline wetlands are marsh, and your freshwater wetlands are forested. In the Everglades, it's the complete opposite. in that the tidal saline wetlands are dominated by mangrove forests, and then the freshwater systems are marshes. And so, yeah, that to answer your question about salinity, yes, salinity is very, very important. And mangroves tend to occupy that tidal saline zone, so not the pure fresh zone.
Yeah. So my final question is, what kind of research do you have currently going on that you think will be really important to land managers in the coming years as you're rolling this stuff out? So what should they be on the lookout coming from you?
Well, guess one key product related to your work is we have a national assessment of the potential for wetland migration. And so a big part of that is quantifying the potential for tidal saline wetlands to move into freshwater wetlands. And then also the potential for both of those systems, freshwater wetlands and tidal saline wetlands, to move into upslope terrestrial systems. And then within those terrestrial systems, what percentage is agriculture versus forest? And so we were on the verge of writing a paper focused on that. It's a national scale, all three coasts, the Pacific coast, the Gulf Coast, and the Atlantic coast. And some of the key take-home messages are that there's a lot of potential for tidal saline wetlands to move inland, but it's often at the expense of those freshwater wetlands, which is something you know from your research, but I don't think it's highlighted enough and communicated to land managers. And the take-home message there is that, yes, there's a lot of potential for wetland migration, but it's often at the expense of these super valuable freshwater systems. And there's very little room for those freshwater systems to move upslope.